Hello everyone, welcome back to another video where today we're going to be doing more Leetcode. Today we're doing the Leetcode medium valid Sudoku. So let's just get right into it. So in this problem, we are given a 9x9 board or 9x9 Sudoku board, and we have to check if it's valid. And we only have to check the filled cells, right? Only the filled cells need to be validated according to the following rules. So each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. And each of the 9 3x3 sub boxes, which are these right here, these sub boxes right here, also need to contain the digits 1 to 9 without repetition. So now, for the rows and columns, that is pretty easy actually, because obviously all we need to do is just validate that there's no duplicates, right? No repetition. And when I think of duplicates, I immediately think of the set data structure. In this case, we specifically need a hash set because we can just get a hash set, and the hash set will store each row and each column. And then we can just loop through the entire 9x9 Sudoku board and then check and validate. When we land on a number, we check the set, go back. If it's not in the set, you add it. And if it's already added to the set previously, that means the Sudoku board is immediately invalid and you can return false. So for rows and columns, that's pretty easy to understand. You'll probably understand it better when I code it up. But the real challenge here is for these 3x3 sub boxes, right? So that's what we're going to get into, because it is just a little clever solution you have to think of for this. So obviously we have these 3x3 9 sub boxes, right? So first I'm going to label the cells, right? This is a 9x9 Sudoku board. So we're going to label it like this. We have 0, 1, 2, 3, 4, 5, 6, 7, and 8, right? And same thing here. You guys understand what I'm saying? And now we're going to do the same thing here with these sub boxes. We're going to label it index wise. So sub box 0 here, 1, 2, same thing on this side, 0, 1, 2 for each sub box, right? So now we're going to do the same thing we did with the rows and columns, in the sense that we're going to make a hash set to store each of these like sub boxes. So the thing is here is, how can we know which number is in which like mapping or like sub box? So you see 6 here. This lies in 1, 1 mapping, right? So this is what the hash set for our 3x3 sub boxes, or we'll call it squares. Our squares hash set, the key will be this mapping here, right? But how do we know that 6 is in this 1x1 3x3 sub box mapping? And this is where we just have to do some clever math. So we have, obviously, find the coordinates of this first. So this is column 4 and row 0, 1, 2, 3. So this is row 3, column 4, right? This is where this 6 lies right here. And let me erase it so you can see it better. So this 6 lies here, and row 3, column 4, right? How do we translate this to being in this 1x1 sub box here, right? We just need to do some integer division by 3. So just integer division this 3, integer division by 3, you get 1. Same thing here with 4. We'll do the same thing with 4 here. We'll do 4 integer division by 3 and then 1. And now this matches the same mapping here. So now that's how we'll find out which 3x3 sub box it's in. And then we can just map the 6 here to this 1x1 or 1-to-1 coordinate sub box here. And then we're going to do that for every sub box in our Sudoku board. And then we can just validate them, making sure there's no duplicates, right? While we're going through. So now that I've gone over that, we can finally just start coding this up. Maybe you'll understand it better if I code it up. So let's just get right to that. Okay, now for the coding up the solution, like I said before, we need 3 hash sets. One for rows, columns, and one for the 3x3 sub grids or boxes, right? And we'll call that squares. So now let's create those. So a hash set for columns, just be a default dict for set of sets, and then the same thing for rows, default dictionary of set, and then finally for squares are 3x3 sub boxes, right? It'll be the same thing. And remember the key here, the keys in this hash set will be the mappings of these sub boxes like 1, 1, 0, 1, or 0, 0, and so on and so forth. So now we've created our hash sets. Now we can get started with looping through the whole 9x9 Sudoku board. And every Sudoku board is going to be 9x9, right? So we can just hard code 9, the value 9 into our loop. So for R in range to represent each of the rows that we're going through, for R in range 9, because there's 9 rows. Same thing for columns. For C in range, for all columns, can't type 9. And then now, the first thing we need to check here is what the problem says. We only need to validate the numbers or the filled cells, like the numbers. That's all we need to validate. We can ignore the empty cells here. So we have to check if we're on an empty cell and ignore it. And if you look at the input down here, the way empty cell is represented is through this like dot or period. So that'll be our first conditional. So if the value of at this row and column is equal to this dot, right? If it's a dot, then we can just skip it completely because we don't care about that. So just continue. And now we can get to the most important conditional. So now we just check the number. If the number we're on or the value we're on has previously been seen in any of these hash sets, any of these, then immediately return false because the whole board is invalid. We can't have a single duplicate in any of the sets. So let's just do that. So if the value we're on is in columns, start columns first, columns at C, the specific column that we're looking at, if it's in that column, the specific column that we're on, or if the value is in the specific row we're on, oh god. Or finally, we'd also have to check if the value we're on is in the specific sub box or 3x3 square that we're on. And remember the key we have to check. The key here is the important part. It'll be a tuple. That's what our key is going to be, a tuple of the pair or the mapping, right? So remember how we're going to calculate that is just by doing integer division of the row we're on and then the integer division of the column we're on. And this will create that mapping coordinate of which sub box, and it'll just check that accordingly. And if they remember what I said before, if there are any duplicates found in any of the hash sets, then immediately return false. And now, assuming that we are at a new number and it's not seen in any of the previous sets, we can just add it to the set. We have to update each of our sets with that value. So we'll do that. Let's just start with rows at R. And remember, they're sets, right? It's a hash map with sets, or it's hash set. So we have to do the .add function to add a value. So we'll just add the value we are on right now. The rows r.add, and the same thing here, columns at c.add. And then same thing with squares here. Squares at the specific key, remember. Floor division of the row we're on and the column. Dot add the value. So and this will effectively update all our sets, right? And then now our loop is basically done here. This is our loop to check if it's valid or not. And if this whole loop runs without returning false once, that means there was not a duplicate. Therefore, the Sudoku board is valid. So then we can just return true if we get out of this loop. And assuming I didn't make any errors, I hope I didn't, the test cases should pass. Yes, they did. And then we could submit it here. And you can see this is a pretty efficient solution. I bet if I hit submit multiple times, it'll go up the approval rating. But yeah, there you go.